to talk about factoring by grouping, okay? Now, grouping is a special case that we only use grouping when there's 4 terms, okay? So when it's a binomial, when it's a trinomial, when it's any binomial or trinomial, you're not going to factor by grouping, only when it has how many terms? Cuatro. Now, someone in my last class asked, what happens when there's 5 terms, okay? We do not learn how to factor a 5-term polynomial in this course, okay? You may learn that in Algebra 2. I'm not actually quite sure, but later on down the road, if you do get up to 5 terms, okay, you'll learn it then. But we only learn up to 4 terms. Gucci? All right. So what we factor by grouping, what it looks like, I did letter A for you guys already, okay? You're going to have 4 terms. The first thing that you need to make sure, write down a number 1, is you need to make sure it's in our favorite form. What favorite form do we love? Standard, baby, okay? It needs to be in standard form. Now, why does it need to be in standard form? It needs to be in standard form because otherwise, you're not going to be able to factor out the GCFs correctly. Once you get it into standard form, then look, you create 2 sets of parentheses. So you're going to draw parentheses around the first 2 terms and parentheses around the second 2 terms. And it's just like when A was not equal to 1. Do you remember when we did that with A not equal to 1? We would draw both sets of parentheses, and then we would factor out the GCF, and then 2 things would match, and then we would write our 2 terms as our factors. The same exact process for factoring by grouping. So we've actually honestly done this method before. So between x cubed and 3x squared, what's the GCF there?
X.
Not just x.
X squared.
X squared, right? So you pull out an x squared and you have x plus 3 left over. Then you move on to the next 2 terms. You have 2x plus 6, and the GCF is what? 2. So you pull out a 2, and what's left over is just x plus 3. This x plus 3 should match the other set of parentheses, and then you know that's one of my factors, and whatever your GCFs were, which in our case was x squared and plus 2, those get combined to become your second factor, okay? Now I want to point something out. Anytime you have x squared plus a constant, that will always, 100% of the time, be unfactorable, okay? Unfactorable, so you cannot move forward. Now, what if, and write a little star next to this guy, we had x squared minus 4? Could you continue to factor x squared minus 4? The answer is yes. Does anyone remember from 7.7 what this factored to? Caden? Nope, don't factor out the negative. Yep. Well, there's this coefficient is 1, right? It's 1x squared, so you can't actually factor out a 2. Andrea? Square root of x squared is what? Is x, right? Square root of 4 is 2, correct? This is a sum and difference problem because the middle term is gone. Do you guys agree? So we're going to put a plus sign and a minus sign for sum and difference. What are my 2 factors, peeps? X plus 2 and x minus 2. So guys, when that sign between your binomials is a negative, when it's x squared minus a number, you can continue to factor, okay? When it's a positive, you got to stop because it's unfactorable. All right, let's do another example. I want you to scroll down to letter C. How many terms do I have? 4. So I know I'm going to use grouping. Before you group, you must make sure it's in standard form. Is this in standard form? Wait, someone refresh our memory. What is standard form? What is standard form? Segi?
When the exponents are from greatest to least.
You're so good. When the exponents are from greatest to least. Now, the 3 has an exponent of what?
1.
It has an exponent of 1, right? But what exponents do we care about? The variable. Does 3 have a variable? No, so its degree is actually 0, so it should always come at the end. Addison, wake up. Okay, so Once we're done with this, we have it in standard form, we're good to go, we start to group. How do I group these? What do I do for grouping? Parentheses around which ones? The first two and the last two. Beautiful. What do I do after that? Factor it. Very good. Matthew, what's the factor for the first two terms?
A2.
Very good. A squared. Factor out an a squared. Someone else help Matthew out. What's left over? Andrea. Yeah, buddy. A plus 3. Hold up. Do you notice anything very convenient? It already matches. So, Salucci, what should we pull out of a plus 3 to keep it the same? A 1. So pull out a 1. Wait, did someone say A? Why can't I pull out an A from a plus 3? 3 does not have an A. Very good, Michael. So we get what? A plus 3. So what matches? The parentheses, a plus 3. We're done once it matches. So we're just going to say, okay, a plus 3 is one of my factors. But my other factor is what? A squared plus 1. It has to be both the GCFs, okay? And if that doesn't make sense to you, start highlighting them so you can see it. It's going to be a squared plus 1 as your other factor. Go ahead, David. We were already doing this. But before, we were starting with trinomials, and we were creating them into a 4-term polynomial so we could use this method. Now we're starting with a 4-term polynomial, and we're getting this, okay? Hey, question. Can I continue to factor this? It is a squared there.
No.
Why not? The plus sign, okay? Highlight it if you don't see it. We're done with this. This is our answer. We're going to circle it. Yes, Christian.
Does it matter, like, if the a squared plus 1 is first or second?
No. The a squared plus 1 can come first or it can come second. Okay? Yes, AJ.
What if it was a squared plus 4?
A squared plus 4 still can't factor it.
So you only
It would have to be a squared minus 1 or a squared minus 4. Okay? Yes, Andrea.
So, I don't get when you said when it's plus you can factor it.
Yep.
Like, I don't understand.
So the only time this binomial, right? Binomial means it has 2 terms, can be factored going forward is if it's a minus sign in the middle. Otherwise, like there's no 2 terms that you can create that would allow this to happen, a squared plus 1. Okay? Matthew.
Sorry. But if it's a minus sign, it wouldn't match. Like, didn't you say that it has to match the a plus 3?
I'm confused on that question.
Like, you know how you said...
Oh, I see what you're asking. Yes. So if we were to change this to a minus sign, then they would match. So Matthew, don't force it to be negative, right? Just keep it the way that it is because you want these to match as your priority. A plus 3 must match. Then you go from there and you're like, okay, the next term is a squared plus 1. But then don't be like, oh, it needs to be negative so I can factor it. No, just leave it the way that it is and be like, okay, I can't move forward. Yes?
So when do you do the sum and difference?
When do you do the sum and difference? If this was a squared minus 1, then you could factor further. Okay? All right, good questions. Any other questions?
No.
All right, we're going to do D. In D, we have y squared plus 2x plus yx plus 2y. If I start by grouping right now, I'm going to be in a world of trouble. Because it was not in what form? Guys, you're going to get stuck if it's not in standard form. So go ahead and change it into standard form. Who can tell me what this is in standard form? Christian?
Isn't it y squared plus yx plus 2y plus 2x?
That would be correct. Y squared plus yx plus 2y plus 2x. Let's go over this. What's the degree of y squared? 2. What's the degree of yx? 2. So do their orders matter? No. What's the degree of 2y? 1. And the degree of 2x? 1. So do you guys agree that their order doesn't matter, but they must come at the end? This is perfect, okay? Now, what do I do once it's in standard form? Colin.
So your parentheses.
Parentheses. Brayden, what do I do after I draw my parentheses and I group them together?
You find the GCF.
Very good. GCF. What's the GCF of the first two, Brayden?
Y.
You're so good. Y. What's left over after we factor out a Y? Austin.
Y plus X.
Very good. What's the GCF of the second two, Mia?
Is it a YX?
Nope. Addison?
2.
Very good. It's a 2. What's left over after we factor out a 2, Addison?
Y plus X.
You're so good. What do you notice?
Match.
Are we happy? Yeah, there's a match. So guess what? That match becomes one of my terms. Y plus X is one of my factors. Hey now, what is the other factor? This is what we keep missing. Karen?
Y plus 2.
Yeah, buddy. Y plus 2. How we feeling? Do we like grouping so far? When do we only use grouping? When there's 4 terms. Can you use grouping when there's 7 terms? Can you use grouping when there's 3 terms? No, you can only use grouping when there's 4. Gucci? All right, now, the cool part about 7.8 is it kind of brings everything back together that we've learned in chapter 7. So if you jump to the next page, okay, I want you to take a look at the steps. What's going on over here? You guys good?
Yeah.
Okay. There's 4 steps that I want you guys to follow when you're just given a generic, hey, factor this problem, right? The first thing you always look for is a GCF, because if you can pull out a GCF, it makes the rest of your problem much easier. Then you want to look for those square shortcuts. Do you guys remember those? If you can take the square root of the first term. If you can take the square roots of the first and the last terms, that'll help you a lot, because then you can use one of the shortcuts. And then if all else fails, do you guys remember the ABC method? You can factor that way as well. And then if there's 4 terms, the only thing to do is to use grouping. All right? So let's take a look at one of these problems. Do not do letter A. Please cross it out for yourself. It is unfactorable. It's going to give you a hot mess of an item. Okay? We're going to zoom in on letter B. I would like to do letter B. So let's start with our steps. Check for how many terms it has. How many terms does this guy have? 2. So can we group them? No, because grouping needs how many terms? 4. So we're going to start with our first step, which is normally GCF, baby. So what's the GCF here? 7x squared. Why is it 7x squared, Christian?
Because both terms have an x squared minimum.
Very good. At minimum, they each have an x squared. Do you guys agree that x to the 4th has more x's than x to the 2nd? So at a minimum, they have x squared together, correct? And both 7 and 28 are divisible by 7. Cute. So when I pull out a 7x squared from both terms, what is now inside my parentheses? McCarvin?
Squared minus 4.
You're so good. So good. That's perfect. Now, I know a lot of you are thinking, oh, we're done. We factored it. But we can actually continue to go further. Alec?
7x parentheses x3 minus 4x.
X to the 3rd minus 4x? You didn't factor out an x squared then. Okay, make sure you factor out an x squared. That way, this entire x squared becomes 1, and this x to the 2nd becomes x squared. Okay? Sophia, what were you going to say?
You can use the root of x to the 2nd and square root of 4.
Very good. This is a sum and difference, guys. We can continue to factor because why, Andrea? It's a negative sign, okay? As long as there's a minus sign, you can continue to factor. X squared minus 4 is going to factor to what 2 terms? X plus 2 and x minus 2. But don't forget the GCF that you factored out. What was the GCF we factored out? 7x squared goes out in front, and now we're completely factored. Cute, right?
You just break up the 4.
What for? So Mia, I'm going to walk you through this actually. Do you agree, Mia, that if we were to FOIL this, let's FOIL it. What's x times x, Mia? Boom, we have that term. You agree? What's 2 times negative 2? Oh, do you agree we have that term? So what happens when we fill on the bottom? What's 2 times x? What's negative 2 times x? What happens when you have 2x minus 2x? Boom. Sum and difference. Do you see it now? Cool. All right, any other questions on this problem? Yes, Andrea. In front of what?
X minus 2. 'Cause, like, isn't it? Oh, wait.
A 1 here?
Oh, wait. Oh, no.
Oh, no, they're being multiplied. They're being multiplied. Okay, David, you good? Just stretching? Okay. Guys, we're going to jump down. We are going to do letter C next. What should I do? GCF. What's the GCF, AJ? 3x. Pull out a 3x. What's inside the parentheses, Antonella? X squared minus 4. Very good. Nick, do you know if we can factor further or not?
Yeah.
We sure can. What can we factor this to?
Square root.
So it's going to be 3x times.
Times x plus 2. And then x minus 2.
Very good. Okay, it factored to the exact same thing. Excellent. Matthew, what's up?
Why couldn't we sum in difference there?
We did sum in difference here.
Oh yeah.
Okay. So when you have a sum and difference, right, where it's a binomial with a minus sign, okay, make sure you continue it on. Now, I have a question for you guys. Can you continue to factor x minus 4?
Yes.
You can?
No.
No.
Oh yeah.
What's the difference between x minus 4 and what we had down here?
X has an exponent.
There's an exponent there. If your exponent is 1 on the variable, guys, you can't continue to factor, okay? Only when the variable has an exponent that's higher than 1, okay? All right, let's do another example. Let's go ahead and look at E. What would you guys do in letter E? Yeah, always start with GCF, okay? Well, actually, can we group this guy? No, why not, McCarvin? There's only 3 terms. Very good. So we're going to take out the GCF, but what is the GCF of this? M. Very good. And Segi, when you pull out an M, what's left?
M to the second. And then M minus 8.
Close. You're missing one thing. I want you to find it. M cubed divided by M is M squared. I agree with that. Negative 2M squared divided by M is not negative M.
Negative 2.
There you go. Negative 2M. Okay? And then minus 8M divided by M is going to be negative 8. Okay. So we did the GCF. Look at what's inside. Can we continue to factor that? Yeah. How? Andrea? Excellent. 2 numbers that add to give me, what's my b value? Negative 2. And they're going to multiply it to give me negative 8. Those of you that forgot, remember you're making your a equal to 1, you're making your b equal to negative 2, and your c equal to negative 8. Salucci, what's up?
Negative 4 and 2.
Excellent. Negative 4 and positive 2. Hey now, a was equal to...
1.
Do you guys remember the process when a was equal to 1? AJ.
M minus 1 and plus 2.
M minus what?
4
Uh-huh.
and M plus 2.
M minus 4 and M plus 2. AJ's so good, he factored that correctly, but if he wrote it like this as his final answer, he'd be missing some points. Karen? Don't forget about the GCF you factored about in the beginning. M needs to come down as well. This is now completely factored. There's a lot of m's. There's actually 3 m's. Do you guys agree? Why do you think there were 3 m's?
It was M cubed.
It was m cubed in the beginning. Do you see that? McCarvin, you good? Any other questions, peeps? Okay, let's do one. Actually, we'll do 2 problems. These will be the last 2, I promise. We're going to do letters A and C. We are going to use factoring to solve equations, okay? So it's the same process that we did before, all right? So what did I tell you when we were solving these equations? And it wasn't just like x plus 4 equals 9, right? It wasn't a simple linear equation. You had exponents with the x's. What did I tell you always needed to have?
Next.
You always need an x, but I always told you you need something. Yes?
So get them all on one side.
Very good. One side of your equation needs to be equal to
Uh,
0. Because you want to apply the zero product property. Do you guys agree? So what would be the best way to make one side of my equation equal to 0? David? You're so good. Subtract 10x. So subtract 10x from both sides. What do I get? Caitlin, Miss Alonso, you're up.
2x to the third minus, plus 8x to the second minus 10x.
Very good. Minus 10x equals? Equals? 0. I love that Miss Alonso kept it in standard form. That was very smart of her. So now, in order to use the zero product property, you have to factor the left-hand side. Do you guys agree? So let's start to factor this. How do I factor 2x cubed plus 8x squared minus 10x? If you can answer this question, I'll let you go. What do you start to do to factor, McCarvin?
Don't you have to like separate them?
Separate them. What do you mean by that?
Like put each of them in their own problem so they can equal to 0.
Not yet, because you haven't factored it. Natalie?
You have to do the GCF.
Mm-hmm. You have to do the GCF. McCarvin, if you can tell me the GCF, then I'll let you go.
The GCF is 2.
No. Caden? 2x is the GCF. So we're going to factor out of 2x. It becomes x squared, okay? X squared plus 4x minus 5 equals 0. Factor out of 2x from every single term. You guys with me? Am I done factoring? You have to do the one inside the parentheses. Go ahead, McCarvin. Redemption time.
Alright, so you need to do the plus and minus, and you need to add to get 4 and multiply to get -5.
Mm-hmm.
So it's -5 and 1. Wait, no, 5 and -1.
Do we agree with McCarvin?
Yes.
I agree. Okay. So McCarvin, what are my 3 factors then? We already have the GCF. It's 2x. This, what's inside the black parentheses, or excuse me, yeah, the black parentheses is going to factor to 2 more terms. What are they?
X squared plus 4 and -1 minus 5.
No.
Wait, no.
Who can help him out? Karen?
It would be x plus 5.
That is correct. X plus 5 is one of them. Where's that coming from, Karen?
It's coming from the sum and then the
Mm-hmm. So we're taking this 5, it's being carried down. What would the other factor have to be? X minus 1 is correct. You'll get one of them, McCarvin. I have faith. Okay? X minus 1 equals 0. What do I do next? Sophia?
You then have to put them all into their own equation. So you need 2x equals 0.
2x equals 0. So that means x equals 0. Very good.
And then x plus 5 equals 0.
Mm-hmm.
Minus 5, that equals 9.
X equals -5. And the last one? X equals 1. Make sure to set a timer. How we doing? Are we okay? Are we staying awake? All right, well, you guys are in luck. I'm done talking. I want you guys to try, you clap for that. I want you guys to try C. You should get 3 answers. Good luck. Have fun. Do your best. We'll compare at the end. Go. We are going to do C. Who got 0, -5, and 5? Who wants to walk me through it? Segi, go for it.
Okay, so first you find the DCF and the 25x.
Yep.
You get x parentheses x to the second minus 25,
Yep.
and then equals 0.
Yep.
And since it's a minus, you need to square root the x squared and the 25. So x squared is x, and 25 is 5.
Yep.
And then it's sum and difference, so x parentheses x plus 5 parentheses and then x minus 5.
Very good.
And then you make them their own like problem. So x equals 0. And then you subtract the 5 on both sides to get -5. And then you add 5 to get +5.
Very good. Guys, give it up for Segi.